These are non-calculator questions. For the most part. I think the first one technically would be too big of a number. But for these non-calculator style of questions, we are going to do them the same way that we were using our powers chart earlier and solving exponential equations. And one of the things that, like, sometimes people get really good at these and say, oh, log 5 of 3,125, I know the answer to that, and they just put the answer down. But if you don't know the answer, you're going to have to do a method like this. And this is what I'm going to suggest. First of all, introduce an x. There's no x in this question, so if you introduce a variable, you have to say let x equals. Just like in polynomials, we had to do let p of x equals. Because if you just start using a new variable without defining it, they'll take off an E3 error on the exam. So I let x equal this, and if I let x equal this, I can change this to exponential form. The base is 5, the exponent is x. And this one wouldn't be asked on non-calculator because it's one higher than on your powers chart. The highest power of 5 that you knew was 5 to the 4 is 625 on your powers chart. This is 5 to the 5. And if we use the same strategy that we did earlier in this unit, if you get the bases the same, I wonder what x could possibly be here. Which means that log 5, because this is what? This is what we made x equal to. We wanted to find out what log 5 of 3,125 was. It's equal to 5. Now, 3,125 is one too high on your powers chart, so this would not be asked on non-calculator. But the second one could be. I let x equal log base 6 of 1 over 216. And so my base is 6, my exponent is x. Are 6 and 216 on our powers chart? Yes. 216 is 6 cubed. And then I can use my negative exponent law, so I get the same base on both sides. This is our goal. If we can get the same base on both sides, then the exponents have to be equal. And we can say, so x would have to be equal to -3. And the last one, I'll change the color here. I'm going to let x equal log base 8 of 2 cube root of 2. And I change this to exponential form. The base is 8. The exponent is x. And I have 2 cube root of 2. Are 2 and 8 in the same column of your powers chart? Yes. I can write 8 as, what could I replace the 8 with? 2 to what power?
Oh, yeah, 2 to the 3.
2 to the 3 is 8. And what can I do with the cube root? I can make that 1/3. And now we have to use all of our exponent laws until we get a power, one power on both sides with the same base. What's the exponent law for a power to a power? Add, subtract, multiply, divide. Power to a power. What's the exponent law if you have the same bases? This is 2 to the 1 and that's 2 to the 1/3.
You add them.
You add them. 1 plus 1/3 is 4/3. So, I've got it to this point. Now I can just say that the 3x has to equal 4/3. Divide by 3, which is the same as multiplying by a third. And I get x is equal to 4/9. And you can circle 4, 7, and 9.